Okay, well, today we are going to work on composition of functions, and there's a couple of ways that these are written. One of them is written as with the little circle in the middle, and with the little circle in the middle, that stands for f of g of x. There we go, f of g of x. And what that means is that we are going to take f, and wherever we have an x, we're going to substitute in the equation or the function g of x. Alright, let's come on over here. And they never give me enough space to write, so I'm just going to grab a pen here. Alright, we're going to write this as f of g of x and close both parentheses. Alright, so what that means is that in our function f of x, x squared minus 3x plus 2, I'm going to put in there that we're going to take x squared, subtract 3x plus 2, and normally if you had something like f of 4, everywhere you saw an x you would put in a 4. Well, we don't have that. We instead have g of x. And g of x happens to be 2x subtract 4. So that means everywhere I see an x, I'm only going to substitute in 2x minus 4. But remember, it's the entire thing. So that's still going to be squared. Minus 3. 2x minus 4. Plus 2. Okay, binomial expansion says that when we have perfect squares, we end up with this as our pattern. We take and square the first term, which is going to give us 4x squared. We take and multiply our a term by our b term and then double it. So negative 4 times a positive 2 gives us negative 8. And then we have the variable x, so that's going to give us negative 8x. And when we double it, that gives us a negative 16x. And then we squared the last term, which gives us a positive 16. Alright, then we are going to distribute the negative 3 to our 2x term, which gives us negative 6x. Negative 3 times negative 4 gives us a positive 12. And then we got a plus 2 there. We're going to combine like terms. So I've got 4x squared. Go ahead and mark that one's been taken care of. We've got a negative 16x, a negative 6x, negative 22x. We've got a positive 16, a positive 12 gives me positive 28, plus another 2 gives me a plus 30. Okay, so that's what we get when we compose f of g of x. Alright, that's D. And over here on the back side, we've got c f of g of x and g of f of x, but our functions changed. Let's go ahead and write those down. So, in this case, f of x equals 4 divided by x, and g of x equals 2x divided by x subtract 2. I'm just writing those down so we can bring them over here. I'm going to write them over here. F of x equals 4 divided by x. G of x equals 2x divided by x minus 2. Alright, again, they don't give me a lot of space. So we're going to take our f of g of x, and again it's going to be f of g of x. And we're going to take our f of x, which is 4 divided by x, and everywhere I see x, I'm going to put instead g of x. So f of 2x over x minus 2. So it's going to look like this. 4 over 2x over x minus 2. Alright. when you divide a fraction by a fraction, you take and you invert the second fraction, and multiply. So this becomes 4/1 times x over 2 over 2x, and then we can divide out a 2 from here and from here, and we get 2x, subtract 4, all over x, and that is our answer for f of g of x. Alright, let me grab another piece of paper here. Now we've got g of f of x. So g of f of x means that we are going to take g of f of x. Alright, so our g of x is 2x divided by x minus 2. So everywhere I see an x, I'm going to put in 4 divided by x. So we get 2 times 4 divided by x divided by, let's see, well, we got another x there. 4 divided by x, subtract 2. Okay, we're going to clean up our numerator. So this would be the same thing as 2 over 1. Let's put that over 2 over 1. Right. When we're multiplying, we don't have to have the same denominator. So in the top, I get 8 divided by x. That is my numerator of my compound complex fraction. And let's see, 4 times the negative 2 gives me, we're actually subtracting that. So these are not being multiplied. These are being added and subtracted. So I have to change this one by multiplying that by x over x. So I will have x in my denominator of the big denominator. And that means we have 4 subtract 2x. We can now divide out this x and this x because they occupy the same position. And what that means is that what is left over is 8 divided by 4 subtract 2x. Well, we can also factor out a 2 from everything. So I can say that's 2 times 4 over 2 times 2 subtract x. I can divide out the 2's, and my final answer is 4 divided by 2 subtract x. Okay. Alright, we do not get the same answer on these. Eventually we'll be talking about inverses. These two functions would not be considered inverses of each other because we do not get the same value for both of them. Alright, so now, this is a really fun part. We are now going to look at D and E of a graph function. So again, I'm going to highlight these in green. And my G is going to be in pink. Okay. What that means is that we come over here to our graph and we are looking for what is the f value that is associated with the g value at 6. So we come over to here to 6. Here's 6. And the g value of 6 is a -1. So now we're going to look for f of -1. So we come over here to -1 and we find our function 1, 2. That means f of g of 6 is equal to a -2. Okay. Alright, now we're going to find our f of 4. So we come over here to 4 and we go up 1, 2, 3. So we're really looking for g of 3. Well, when we come over here to 3, the g of 3 is 1, 2.
is it? What is